Sorry for the long time. A warm welcome to everyone. So we will start with a short introduction to Batrec, to our company and our company behind. So it's Veolia. Here, Veolia is responsible or is working in the business units of water, energy, and waste. And for hazardous waste in Europe, we have a subgroup named Batrec Industries with more than 4,000 employees. And we are located in more than 10 countries. And in Switzerland, we have four facilities: Emmenbrücke, Basel, Rubigen, and in Wimmis, Batrec. And in total, we have four companies in SAPI who are responsible for battery recycling. It's Eurodys in France, it's Cellulor in France, Batrec in Belgium, and we in Switzerland. So Batrec is a bit special. So everything started with battery recycling. So in this building, there we have our furnace, our electric arc furnace for the recycling of household batteries. In the past, it was allowed to use mercury inside these batteries. And so we developed some know-how in the treatment of mercury waste, because we produce the mercury-rich sludge, and this sludge we have to treat. And that was the second production unit we have, the mercury waste handling and treatment. To be more stable, then in 2013, the plan for the reactivation of activated carbon was built. And then last year, our mechanical separation for the lithium-ion batteries was in commission. And so yesterday we reached 1,000 tons of shredded lithium-ion batteries, which were separated in this mechanical separation. As Christian told, we were founded in the 1990s. Turnover or revenue is around 20 million, and at the moment we have a bit more than 100 employees at Batrec. So here are our different business fields: reactivation of activated carbon, treatment of mercury waste, stabilization of mercury, and the battery recycling. Battery recycling, here you see just 1/4 of all, but in total it's we have 70% revenue from the battery recycling with the melting process and with the mechanical treatment of lithium-ion battery. Just an overview for the other production lines we have: the reactivation of activated carbon. Of course, it's a topic of carbon footprint. So if we are able to reuse the activated carbon because we can remove the pollutants and also, for example, some mercury there, then it's possible to reactivate the activated carbon, and then it's of course it has a lower food or carbon footprint in comparison to produce new activated carbon. There we have 3 lines. We heat the material up, have recovery of the mercury, so a washing step here to produce a mercury-rich sludge. This sludge we can stabilize and can distillate the mercury there. Then washing process to recover the sulfur from the off gas. Then drying unit, filter unit, and in the end chimney. And the wastewater unit, it's also nothing special. We participate the heavy metals, have a filter press cake, and then different filter systems to have a clean wastewater. Another project, we started 5 years ago, was treatment of mercury waste. It's located in South Africa, and there you can see what it can be if you say, okay, we are able to treat mercury waste. You see here a warehouse, or maybe it's more in shithole. So really something something special. And then the government decided, okay, we want to treat all these material there. So we started with an estimation of 3,000 tons. In total, it will reach 4,500 tons. Stabilization of mercury, it's a topic because of the Minamata Convention that the amount of liquid mercury should be removed or should be reduced in the market. And so we developed a process to form cinnabar. So we mix the mercury, the liquid mercury, with an organic solvent to produce cinnabar. And this is the only non-toxic compound of mercury. And this material can be deposited in salt mines, that it's safe. Every gold mine, or for example, in the past, chloralkali plants used mercury or produced mercury, and they are forced to have a stabilization process of their mercury. And now, yeah, to the biggest field of Batrec, so battery recycling. The Inobat system, or the Swiss market, is responsible for 90 to 95% of the revenue. But we are also able to recycle some kind of batteries from other countries, for example, from France, from Belgium, Sweden, or the Netherlands. And there we are able to recycle button cells. So this is the only chemistry or cell type where it's allowed to use mercury inside at the moment. And also we have a small amount of or capacity for the recycling, or more in destroying and then stable process to remove primary lithium batteries from the market. All these batteries are going to our electric arc furnace, so to our pyrometallurgical process. And yeah, for this year, the estimation is that we receive 2,700 tons of unsorted household batteries and around 800 tons of lithium-ion batteries. What are our capacities? So for sorting household mix, more than 3,000 tons. There we will invest for next year in an automated sorting system. Then yeah, capacity is more than 900 tons for the sorting of lithium-ion batteries. In the melting furnace, we have capacity of around 2,300 tons, 2,500 tons of batteries. Then we pyrolyze nickel metal hydride batteries. So they are not melted, they are just pyrolyzed. So we vaporize the plastic, can crack the batteries, and these dry nickel scrap because of the composition, 40% of iron, around 35% of nickel, is a good raw material for steel manufacturers. Then also in the melting furnace, capacity of around 150 tons of button cells, and yeah, also some primary lithium batteries we can recycle. For the recycling of lithium-ion batteries, we have a capacity of for shredding of around 1,500 tons. So at the moment, we see, okay, we receive 800 tons, so we can double the capacity, or we can double the throughput. And for the mechanical separation, so we started last year in November. We reached now 1,000 tons, and since 2 months we are working in a 2-shift system that we hope to reach 2,000 tons at the end of the year. What you can see on the left hand side, is that the return of collected batteries in the household field is nearly constant, and there's a continuous increase of lithium-ion batteries. But in comparison to the put on the market, we are more than 5 years behind. So in comparison to 2018, just 1/3 of the material is coming back at the moment, and that's good. So we can use or we use the lithium ion batteries longer than expected, and yeah, for us it's time where we can develop our processes. Topic of sorting. Here you see the different drums of Inobat. So the green ones for the household batteries, the black ones for lithium-ion batteries, and the violet or purple ones for the from lithium-ion batteries from dismantlers. So they have a filter on top because there the risk is higher that we have some fires after the dismantling process. Here you see our sorting line for the household batteries. So we feed the material, the unsorted material, into this bunker. Then the material is going up. We have different sieving steps where we sort the material by size. The bigger parts are going to this sorting cabin, and the smaller ones, so the fine fraction, the AA, AAA, C, D batteries are going to the second sorting cabin. Here you can see the outlets. So we are sorting in these cabins by chemistry. So NiCad, so nickel cadmium batteries, nickel metal hydride batteries, e-scrap, waste, lead batteries, alkaline batteries, and e-cigarettes as well. So normally e-cigarettes are electric waste, but the risk to dismantle these lithium-ion batteries inside is really high, and that it's the reason why we are allowed to shred e-waste to reduce the risk we have for the dismantling there. The melting process, we can divide this process in 3 areas. So the hot area, the off-gas treatment, and the wastewater treatment. So we feed the material to our shaft furnaces. So we have 2. So during campaigns for nickel metal hydride, we use one shaft furnace for the nickel metal hydride batteries and the other shaft furnace for the pyrolyzing of the alkaline batteries. The aim is to vaporize all the plastics, to vaporize the moisture and the electrolyte, and if there's some mercury available, we also will vaporize this mercury. So this mercury and also the pyrolysis gases are going to this post-combustion chamber. Then they cool down the off gas. The mercury is dissolved in our wastewater. It's an acidic wastewater there, and this wastewater is treated in our recycling plant or for the reactivation of activated carbon. They have much higher mercury content in their wastewater, and so it's good for us that we separated 3 years ago these 2 wastewater lines. Then we also have a back filter, activated carbon filter, to clean our off gas. The dry material we receive after the pyrolysis process is going to this electric arc furnace. There we have temperatures of around 1500 degrees. So we form the ferromanganese. It's settled down because of density. On top we have the slag where the reaction will happen. For example, the reduction of zinc oxide with carbon to metallic zinc. Then the metallic zinc will be vaporized, and we can condense this metallic zinc in the zinc splash condenser. So This is something special for Batrec because we are the only one who is using liquid zinc to condense this zinc from these off gas. We have a carbon monoxide atmosphere here, and this off gas is washed here, and then we can use this carbon monoxide as burning gas for our pyrolysis process and for the post-combustion chamber. So it's an internal circuit there. Another advantage, what I mentioned before, is that we separated our wastewater lines. So we do a heavy metal precipitation here. We can bring this to the filter press, and the filter press cake contains nearly no mercury. And that's the reason why we are able to recircle this filter press cake to our input material. And so we have an internal loop for this filter press cake because the content there is 30 to 40% of zinc. And this is something where we can increase our recycling efficiency. So for our output fractions, we have some filter dust here. We have slag, which has to be deposited at the moment because in Switzerland it's not allowed to use this slag, for example, as construction material. But there we are looking for outlets, maybe in Europe. Our ferromanganese. This is something, for example, for foundries or steel manufacturer. Then we can recover metallic zinc, and we have some skimmings here. And because of the process, there's 1/3 of these skimmings is metallic zinc, and this is something we can remelt here to increase our recovery rate of zinc. So, and then these skimmings are going to another recycler to remove the rest of zinc from this material. Then, if we are following the wastewater, we have a reactor where we can participate some mercury or have a reaction. Then here in this settle tank, this mercury sulfate or iron sulfate can settle down and is pumped back to the heavy metal precipitation process. And then we are using sun filter, microfilter, and in the end we have a storage tank. All our wastewater is analyzed, and if the analysis is fine and we are inside the limits, then it's going outside. Here you can see our products. So mercury. For this year, it's the last year where we sell mercury because it's also a top social topic. Then the ferromanganese and metallic zinc. The slag I mentioned, there we are searching for some outlets, and the pyrolyzed nickel scrap. Now to the mechanical separation of lithium-ion batteries. So we start with a mechanical treatment. So we have a two-step shredder process. It's a wet shredder process. So after sorting, all our batteries are in boxes, in water boxes, because it's not possible to use or to discharge every e-bike battery or smartphone battery or other kinds of batteries. So this is something where we use water for discharging, and of course also to reduce the risk of fires, because you need three parts for a fire. So oxygen, this is available because of the active material. You need something burnable, so this could be the separator foils, and activation energy. And because of the storage in water, we can remove or reduce this activation energy, and so we are relatively safe that we don't have fires in our storage. Then, for example, here you see a lot of e-cigarettes. We turn the boxes, bring this to the conveyor belt and feed the shredder unit. After the two shredders, we collect the material in these filter big bags. So after shredding, with splashing water inside, we dissolve the electrolyte in this wastewater, and so we have, or our goal is to shred minimum once. So there we are also nearly risk-free, but that we have some good batteries inside this shredded material. So also there the risk of fire is limited for this material. Then we have a drying process by time, and then it's going to our mechanical separation. And there the goal was really that we want to have a dust-free process. So the employee has contact to the material at the beginning. So we put these big bags inside with the shredded material. Then we train up these big bags to the middle. Then it's coming down. There's an automated cutting knife for the material. Then we have some screws here on the bottom to feed the material to a hammer mill. The reason why we use a hammer mill is we have two shredders and we want to have a second impact for the material, because you see here, so this is something where we shred the material, but it's not liberated. And because of the second impact in the hammer mill, we can increase the liberation rate of the black mass. And that's the reason why we decided to use a hammer mill. Then after the hammer mill, the material is going to the first sieve. There we can remove or can recover our first quality of black mass. After this sieve, we have a magnetic separation. The material is then going to a zigzag sifter. So everything what is too heavy for this airstream is falling down. It's there are some parts of aluminium casings, for example, but the most material is are the plastic casing from the batteries. Then we are using a balling mill to form copper and aluminium granulates. And this material is sieved on our second sieve, where we have also our second quality of black mass. The oversized fraction are mainly the separating foils we can collect here, and the three particle sizes between are going to our separating tables. And there we can have a heavy fraction and a light fraction. And the heavy fraction is the copper fraction, where we are going for 2 tables for pure copper. So we reach there a copper grade or copper purity of 98%. And the aluminium and the plastics are going to the light fraction. And because of the particle size, so 1 to 3 millimeter, for the third separating table, we are going to a metal fraction. So we have the copper and the aluminium in one fraction, and the plastics are in the light fraction. So every machine is exhausted. Everything is going, or everything what we exhaust is going to a big filter in the end. And this filter dust is going to the third sieve we have, so third quality of black mass and another fraction of foils. But so we can say that we have not 100% dust-free, but it's a really good atmosphere to work also for the employees. and we can say that we have a working process there. So some pictures, photos more in detail or realistic ones. So this is the complete plant. Here you see the feeding unit. Now it's closed, just open for the pictures. Hammer mill, balling mill, the separating tables, and here our third level with the different sieves. So also topic next week is the ICBR in Basel. So we are participating with a plant tour on first day. At the moment, it seems that all the places are booked, but from the past, it's normal that some people cancel the tour, and so maybe there's something free on Wednesday to book the tour for Thursday, and we are open to host you at our facility. Here you can see how we start with these e-bike batteries and small lithium-ion batteries. Some picture of our products, black mass. We have a steel fraction in comparison to the EV market. There are a lot of cylindric cells in the power tools and consumables, and that's the reason why we have much more steel in our shredded material. So there we are talking about 10% copper fraction and the heavy plastic fraction from the casings. So we are looking to the future. I told you automatization of household mix sorting. There, hopefully, we will have for the AA and AAA batteries automatic sorting system up from February. So commission is planned for January and beginning of February, that we can optimize our sorting quality, and on the other side reduce the pressure to our or on our employees to have enough sorted material for our melting furnace. Then optical detection of batteries from the lithium mix. So lithium-ion batteries is just an over name. So there are a lot of different cell chemistries between, and if we shred everything together, it's not possible to separate nickel cobalt containing material from LFP battery material, and also lithium titanium oxide, just lithium cobalt oxide, maybe also in future sodium ion phosphate batteries. So this is really a topic for us to optimize this sorting, that we can produce higher purity in our products, and on the other side also to optimize the sorting process, because we see at the moment, okay, we have a volume of 800 tons, so this is possible. But if you remember, more than 4,000 or 5,000 tons are going or went to the market last year, and so we have to multiply our sorting capacity, and this is something where we start to increase our sorting capacity with optical detection. Then the topic from the shredding process is wastewater treatment. So in Switzerland, at the moment, we have no law for the recycling efficiency or to recover the lithium. But if we accept batteries from the European Union, for example, we have to reach these recovery rates for the lithium. We see at the moment it's possible with our process, but of course, if we have a higher lithium recovery rate, then it could be also an advantage in comparison to other contributors in the market. Then also an off-gas treatment to remove volatile organic compounds from the off-gas is a topic. And some tests will be made at the moment or in future that we, for our pyrometallurgical process, has to treat alkaline black mass from our sister company in Belgium, and that we start to pyrolyze lithium-ion batteries in our shaft furnace to see if we have some advantages there. But on the other side, if we are looking, for example, to an aluminium casing from an e-bike battery, or also some e-cigarettes with an aluminium casing, then the pyrolyze process is not the best way if we melt all the aluminium there. This, or at the moment, we are focusing on the household batteries and consumable batteries, but we have also an dismantling room with an exhaust system and also fire detection system. So we are able to dismantle EV batteries or, for example, home storage batteries. So it was not our focus, but we are able to do this, and we are working there also together for the dismantling with partners. So if there's something you want to recycle, then feel free to contact us. So thanks for your attention, and yeah, I think maybe there are some questions because there were a lot of information inside. And,
well, good. Thank you very much, Philip. That went very well, after all, I have to say. So now we are open for question here in the audience. Please raise your hands or ask in the chat if you have questions about the recycling processes from Batrec. So maybe for the start, I want to repeat something that I think you explained, but it was about the mercury treatment and the, how you call that, the cinnabar, right, that you create. And did I understand correctly? There is basically no use for the cinnabar, so it's really just a treatment in order to have the mercury in a non-toxic way that this can be stored. Is that correct?
it's correct, yeah. In the past, it was used, for example, also as pigment in painting industry, but yeah, so now there are other materials are available, and yeah, I think so. At the moment, it's deposited in salt mines, but yeah, maybe in future it could be a source there, but at the moment there's no usage. Yeah.
Yeah, but it's incredible. Huh? First, we offset the waste to an African country, then we get it back, treat it, and then we have to store it again. Huh? So we definitely have to do better with lithium-ion battery. Yeah, so circular economy is really, well, still a big challenge, but something that we should aim for. Okay. Yes. Now I see that Daniel Landmann has a question. I will allow you to talk. Give me a second. So now you can use the microphone and the camera too.
Perfect, that works. Thanks a lot for your overview. Daniel Landmann here with ABB. I have a question about where do you see the value? I mean, we've seen that you recycle basically, if we talk about these e-bike batteries, right? I mean, you recycle them with all the housing on it, all the electronics on it. My question is in that direction. I mean, where do you see the value if you would just get the cells as they are? I mean, is there like an added value, or is that basically in your process, is that negligible?
So we receive all the batteries and then the batteries are waste. But of course, it's a topic if you have a dismantling process before, then you can remove the casing, for example, or could also remove the electronics. But yeah, I think for an e-bike battery could make sense. So it's a topic of calculation and of revenue you have. But if you see, for example, to all our smartphone batteries and from power tools, for example, this is sometimes you have 4 cells inside, and then you can calculate, okay, how much time do you or do you need to dismantle this battery and then to remove everything in comparison to shred these completely. Then, so for us, of course, it would make sense to have just the cells, and this is something, for example, for the EV batteries. There are some players on the market who say, okay, we shred the complete battery. So I think, or in our mind, is this is not the best way. So we want to remove the casing before and then shred just the modules. And also there, it's possible to remove, for example, the cooling plates in the end of these modules. And then, because it's pure, or most of the time, it's pure aluminum, and it's something where you have a pure fraction. And so I think there it makes sense. But then you have a lot of more cells for shredder process in comparison to just yeah, the low value of these few cells from the e-bike. Yeah, e-bike battery, maybe there's a switch, but for example, from vacuum cleaner, there you have some, or just 2, 4, 6 cells inside. I think this makes no sense there.
Okay. Okay, thanks a lot. May I have a second one?
Of course, from my side.
So you also showed in your outlook, right? I mean, that you're going more and more to the refinement of cobalt, of nickel, I guess. And I just wanted to ask you, I mean, is that something that has to be developed from ground up? Is that technology already available? And when are you planning to go online with that?
So at the moment, or in our company in Switzerland, we are just going to produce black mass in the company. So in France, there's a hydrometallurgical process to extract the different elements, so nickel, cobalt, of course, some copper, and then to bring this to pyrometallurgical or to metallurgy companies, for example, to produce pure copper or to have a pure nickel salt, which you can bring back to the battery production process. I think in Switzerland, the volumes are not that high that we can have an own process here in comparison, yeah, for the big volumes of the metallurgy companies, for example, in Belgium, North Germany, or also Finland or so. Yeah.
Okay, cool. Thanks a lot.
Okay, there's another question from Peter Kromanacher. Well, now you can talk. I'll allow you also the camera. Hi, Peter. For the time being, you're still muted. Can you unmute?
Okay, sound works.
Yeah, very good.
And cam works. Okay, very well. Hello, Christian. Hello, Philip. Thank you very much for your presentation. My name is Peter Krummenacher. We are working with the battery passport. We are developing the digital battery passport. And I wanted to ask you, like from 2027 on, and this is going to be a must to carry the digital battery passport. I wanted to ask you whether this will ameliorate your situation, knowing the material composition of a battery that you have in front of you. Will that change anything in the process that you had just described, knowing the material inside and maybe treat it differently then?
So, on one side, so we have to look for the future. So I think at this time we don't reach our full capacity with consumables. So I think then we also accept EV batteries. And of course, if you know which material you have in front of you, then you can have, for example, also campaign where you can produce a higher purity in your black mass. Because, for example, if you have and specific nickel value there, or for EV batteries with higher nickel content, then it's something where also some trader or partners to take our black mass ask for specific fractions with high nickel content, or in comparison from the consumables, we have a higher cobalt content. So if you can separate this before and say, okay, for this week we will have a campaign with high nickel containing black mass, and then the next week maybe a campaign with LFP batteries, and then the week after for consumables with high cobalt content, then of course you will have advantages on the market, because everything you can sort before, or before, will result in higher purities in your products.
Okay, thank you, Philip. That makes sense.
Good. Thanks for that. We have another question from Daniel Chatuni. Daniel?
Yeah. Hi. Thank you, Philip, for this interesting presentation. I have a question about the economics when you do recycling. If I understood correctly, in France there is recycling where the critical raw materials are really extracted to some higher purity. So is this today already beneficial financially to extract cobalt, nickel, copper, for example, from NMC batteries, to sell that afterwards? Is that can you make money with it, or is the process more costly than the material inside?
So at the moment, the hydrometallurgical process in France is in commission. So I can't say how or which purity they will achieve in the end. And of course, if you have a pure fraction there, then it's something where you can have higher prices or higher revenues in the end. But I think it's also a step-by-step process. If you start with the extraction, then maybe you will have, for example, an electrolysis process to produce pure nickel. And this is something new for Veolia, because in the past we burned everything or brought this to incineration processes or to landfill. And now we have materials, that we have raw materials in the end, and we can sell. And so we have also to develop our processes there. But I think for the future it is possible to have a positive EBIT there. Yeah.
Mm-hmm. Okay, thank you.
Okay.
Okay, we have soon 5 o'clock, so one last question from Dario Valde. Microphone is on, camera's on. Yes, Dario.
Okay. Hi, everyone. Thanks a lot for this presentation on this really interesting topic. I have a quick question regarding the EV batteries. So how do they get to your manufacturing plant or to your recycling plant? I mean, if we purchase one battery, then we pay a certain fee to Inobat. And I now want to ask, how does the battery now get to you?
So for the Inobat system is just responsible for the consumer and household batteries. So for EV batteries, there's an own solution, and so there you will, if you want to bring the material to us, then you will receive a special offer for you for your EV battery. So it's at the moment not located in the Inobat system, the EV battery. And then, of course, it's a topic. For example, if you are a recycler or if you are a waste collector, do you have own trucks, for example? If you are able to transport the battery to our facility, then of course we shouldn't offer this. Then we just offer the discharging, dismantling, and the recycling of the material. And of course, it depends on the cell chemistry inside, which price this process has.
Okay, thanks a lot. But do you know if the price for the process gets paid by the Inobat because you have this fee you pay when you buy the battery, or is it a thing that you have to pay by yourself as a company?
So if you buy an EV battery or an EV car, then you are free, or the seller are free to pay this fee before. So because they have their own solution for these batteries. If you buy, for example, a laptop battery, then you will pay this fee with your, if you are buying these, when you are buying the battery. And then for example, the supermarket will pay this fee to Inobat.
Okay, but if you, as a manufacturer of electric vehicles, you pay the fee if you buy the battery, and then you can also kind of use Inobat to bring it back, or?
No, it's different. Maybe I can explain that a little bit. It's called Branchenlösung, and there are different Branchenlösungen. So one is Inobat. So this is, as Philip already mentioned, for all consumer batteries, e-bike batteries, power tool batteries, and so on. And there are the importers of cars, and there are two different solutions. One is from the what is called independent importers, so unabhängige importer. They have a known solution together with Sense, and they pay a certain fee to a fund that is within the Sensor organization. And Auto Schweiz has a different system. So they set up a company that is called Sestorec, and each importer has monthly to send the registration to Sestorec, and then Sestorec forwards that to the Bundesamt für Umwelt, so the Federal Office of Environment. And then when the car or the battery is end of life, then each manufacturer has to pay a fee to the recycling company, and the recycling company can be Batrec, can be Librec, but can be also somebody outside of Switzerland. That's the system in Switzerland for now, which is slightly different than, for example, with the new battery regulation that we know from the EU, which you have to pay upfront a certain fee for recycling.
Okay, thanks a lot.
Good. As we are already slightly over time, but we started the webinar a little bit later, I would suggest that we close for today. Thanks again, Philip. Thanks to Batrec for the interesting insight, and I hope to see you next
week
at the next webinar. Yeah, and next week at the ICBR. So I think there's still a chance, if you are interested in further insights to recycling, to register for the ICBR in Basel, and maybe even have a site visit at Batrec. The other site visit is fully booked, what I heard. Thanks. And